Good morning, mathematicians. Welcome, welcome. Definitely seems like the subscriber climb has subsided. We got that nice juicy boost from my Vixra paper. Now it seems to be decelerating. Second derivative is negative over here, but the function's positive. The derivative is still positive, so we love to see it. You are not late today. Is it that you're not late, or is it that I'm early, so you're extra not late today? Wait, yeah. You're not late. Because I don't know what I'm saying. Hello, tenacity. Yeah. Okay, so we're back. Trying to understand this paper on the FPP conjecture. When are we gonna start listening to research? Well, right now. Or you mean my research? Soon. I could go back and talk about my last preprint. And hopefully soon I can start talking about my next preprint. Annals of Math audiobook. Wow. I could, what could I do? Yeah, what if I just started recording myself just reading Annals papers out loud? Maybe that should be part of the YouTube memberships. So a rod to get you filled in. We talked about a couple of random viewer questions, but mostly we just read through more of this FPP paper. Yep, that's pretty much it. Technical Minecraft is all about listening to research. Interesting. How does one pronounce a commutative diagram? I'm not sure. Right. Oh, you mean because, when I'm reading the Annals paper? Well, you could just talk about that, that the arrows commute. Just say the arrows, right? You could be like, oh, A composed with B is C composed with D. Yeah. So that wouldn't be too hard. Now, I mean, that's for a basic commuting diagram. For a very big one, yeah, life is hard. I guess you just, for a very big one, you just, because it would be equivalent to just writing out a list of all the compositions that are equal. So yeah, I guess some transcription would be involved. Okay, we looked at this. But it seemed complicated, so I felt like skipping the details. But that's a sign I should go back and write out the details for myself later or right now, but I'm not going to do it right now. I should do it right now, but I'm not going to do it right now. Left as an exercise for the listener, yes. You said it as a joke, but it actually sounds like a good idea. Well, maybe. Yeah, I mean, maybe it would help. I don't know. I don't like running indoors, but sometimes I do run indoors. And if I do, sometimes I'll watch a lecture or listen to a lecture while I'm running. So yeah, maybe there's a market for me reading papers. I could start with like classic math papers or something. Okay. Let's sink into things here. We've got an infinitesimal parameter. Am I teaching this semester? I am not. I am just a big boss man in charge of the Math Help Center, basically. If I was teaching this semester, I'd probably make more videos related to that course. If it was an interesting course. Not if it was just calculus or linear algebra. But yeah, maybe if I TA next semester, I'll probably make related content, I imagine. Suppose we have an infinitesimal character, and suppose we've got a Langlands parameter of the infinitesimal character, and suppose even more so that we have this, then, okay, interesting. So this thing is going to be bigger than this. That makes sense, because what did we conclude last time? I think, yeah, maybe I'm losing my mind, but I thought we came to the conclusion that, like, in the unramified case, that's always the whole group. Right? Because, no, sorry, not in the unramified case. If there was, we're going in circles here. Hello, Fimnal. You caught the stream earlier today. Right. It was if we had a unitary rep. And then we should expect this to be, if FPP holds, we should expect this, then that'll give us everything. What are we reading? We are reading the FPP conjecture for p-adic groups. Yeah. This is day like 3 or 4 of slowly going through this paper. So where were we now? We were here. Okay. So take this. Take a representative of here, factoring through the levy. And the dark magic of yesterday, yeah. And centers in here for the maximal torus. This is P positive, so it's should be dominant. Yes. Namely, for anything here, we have this. Okie doke. And from proposition 2.3, we should have that this is this. Edward Binns is going to be honest. You understand 10% of what I work on, but you like putting the stuff on in the background. Will you work on your PhD? Well, I am, you're most welcome. I also sometimes, I'll listen to all sorts of random stuff while I'm working on research or grading or what have you. So I'm glad that I can be serving that same function for you. Yeah. How much Fourier analysis does one need to study modular forms? And would you say Fourier analysis is representation theory in disguise? Yes, I would certainly say Fourier analysis. I was just ranting at some undergrads yesterday who were taking a course in analysis 3, and I was like, oh, wow, that's just representation theory. Yeah. It really is. It's not even a disguise. You're just decomposing an L2 representation, basically. But how much Fourier analysis does one need to study modular forms? I don't know. I guess it depends on how deep down the rabbit hole you want to go. I think depending on what you do with modular forms, I think there's a lot you could say with just the very basics of modular forms. I don't think you need to get particularly deep with it. But yeah, just a fundamental understanding of basic Fourier theory. Actually, now that I'm saying that, I think even yeah. But then, yeah, certainly things are gonna get crazier as you keep going. Because I mean, really, if we're gonna talk about automorphic forms, we should be talking about Fourier theory on like groups, and I guess on like adelic groups and stuff. But if you just want to get started with like basic classical modular forms, I don't think you need to go do a deep dive on Fourier analysis before you get started. Like, you can learn these things as you go. What prereqs do I think you would need to understand 2 sentences in this paper? Prereqs, well, I guess it depends on the sentence. Like, this sentence is not so bad. I don't know. This sentence is not so bad. It basically tells you how to define a homomorphism of 2 complex Lie groups in terms of their underlying Lie algebras. But so it depends where you're coming from, because that means like you need to know manifolds and linear algebra and stuff. Surely there's okay, let's see. This is probably the easiest, the least prerequisites of any sentence in this paper. Local field. Okay, so you need to know what local compactness means. Actually, you don't even need to know that, because you can just believe a theorem that says, oh, these are the local fields. And then you can just say, okay, so you need to know both fields and their extensions. The k points of a connected reductive algebraic group. Actually, I guess there's a lot of words there to understand. It's still probably the easiest. Oh, here. Okay, look. You don't need any background to understand this. This conjecture was proved by Dougal Davis and the third named author. That doesn't require any mathematics background. So, yeah. So, life hack. Just read the introduction and you can find understandable sentences. When you were a baby undergrad, nearly everyone and their grandmother used Silverman's elliptic curves for undergrad theses. Well, it's a cool book. Go check out my interview with Silverman. BT dubs. Getting into it a little is you have to give a seminar talk in modular forms in elliptic functions. In modular forms seminar. Cool. That sounds cool. The least prereq sentence is one that you understand less than 5 words in. Yeah. It do be like that sometimes. A lot of those words can be black boxed, as Arad said. Yeah, I mean, like, yeah. And you know, for a lot of it, you know, you can just imagine, oh, the k points of a reductive group. Just think about GLN, right? Invertible matrices with, like, p-adic number values. If you think about that, you should be good. A field is a set. Yay. I mean, technically everything's a set, depending who you talk to. Like, most things in math are sets. They could be types. A local field is just a field that is local. That's some great block boxing there. Imagine a baby learning language for the first time. They just block box everything. Yeah. Yeah. I mean, I just had the thought, actually. Babies learn by babbling, right? And just saying words that they don't understand. And so I just had the thought that, like, sometimes it's annoying when there's like these people, usually it's just undergrads, certain undergrads that like want to seem smart. And so they just babble about words they don't really understand. And I always find it annoying. And what bothers me more is sometimes, like, I've noticed that other undergrads then will think that undergrad is like really smart, and then they get intimidated by that person. And then that's the thing that makes me mad, because I'm like, there's people who you should actually be intimidated by, who are your peers, who do really well. But it shouldn't be those people who are just running their mouths, But now that I see this analogy with babies babbling, maybe I shouldn't be upset, because that's kind of the learning process, right? Just like when a baby is learning language, they just sort of try random stuff. And that's how you learn what works and doesn't. So maybe I should view this, when someone's just sort of talking about random nonsense, I should view this as their babbling learning process. You know that advice for beginning undergrads by Vakil? That's his point in it. Oh, is it? Or advice to prospective students? I haven't read that for a very long time. Let's take a look. You guys like that? Okay, I don't want to read this whole thing. This is all very good advice, and you should read this whole thing, but I don't feel like reading this whole thing right now. But you should go read it now. I mean, no, don't go read it now. Listen to me now. Give me views now, and then go read it. You think mathematical babbling is like making mistakes in exercises? That's true. I mean, making mistakes is an important part of learning. So, yeah, I don't know. They always get wrecked in grad school. I've never, well, I don't want to say never, but rarely have I met a grad student who postures like that, because at that point, yeah, I don't know, you're going to get called out by someone on your BS. Oh, it's in the last bullet. There's a phenomenon. Phenomena. Phenomene. Phenomenu. Phenomene. Phenomene. Go to colloquia fairly often, so you have a reasonable idea of what is happening. It is amazing what can become relevant in your research. Huh? I don't think that was the one. A different bullet point, you mean? Huh? Oh, Here's a phenomenon I was surprised to find. You go to talks, hear various words whose definitions you're not sure about. At some point, you'll be able to make a sentence using those words. You won't know what the words mean, but you'll know that the sentence is correct. And you'll be able to ask a question using those words. You still won't know what those words mean, but you know the question is interesting, and you'll want to know the answer. Then, later on, you'll learn what the words mean precisely, and your sense of how they fit together will make that learning much easier. The reason for this phenomenon is that mathematics is so rich and infinite that it is impossible to learn systematically. And if you wait to master one topic before moving on to the next, you'll never get anywhere. Instead, you'll have tendrils of knowledge extending far from your comfort zone. And then later you can backfill those tendrils and extend your comfort zone. This is much easier to do than learning forwards. Caution. Backfilling is necessary. There may be a temptation to learn a lot of fancy words and use them in fancy sentences without being able to say precisely what you mean. You should feel free to do that, but you should always feel a pang of guilt when you do. Nice. Wow, that's a great quote. And I feel like I should keep that in mind in my day-to-day life, especially when I come across young people who maybe seem like they're annoying and posturing. Yeah. Math, SMR, seductively reading the latest Schulze papers. This is $1 million idea. Yeah. Maybe that'll be behind the paywall. I do feel like this morning in particular, my voice has an extra bassy quality that I'm kind of into. I should definitely sing. I should definitely try and record some music this morning or something. Programmers entered the chat. Zero indexing. Enjoyer spotted. Yeah. Miniseries on perverse sheaves. Yeah. I should do that. I probably will do that at some point. I mean, I guess kind of the office hours have been like that, but yeah, maybe a like pre-recorded course. You feel like I'm talking about you as an undergrad, but every time you thought you were being too abstract, you got insanely paranoid and tried to force yourself to find like 10 examples. Good. Okay. Let's turn back to this thing that we're halfway through. Take any point in the orbit associated to a Langlands parameter. According to, what's that, Gross Reader, we can complete this to an SL2 triple. Agreed. Such that this is true. Yes. And in particular, this should be true. So 3.4 implies that this is in here. You feel confident that you could motivate each jump in abstraction from monoids to spectra to a sufficiently patient 5-year-old. I want to see one of those, what's that one where they have one person like debate 20 people? Like, I want to see Boris in the middle, a Jubilee video. I want to see Boris in the middle and 25-year-olds around him while he explains, goes from monoids to spectra. You find it interesting that things are getting too abstract. Sit back and realize you should never have clicked the end left link. Wow. Most universal mathematics experience ever. Guilt tripping yourself into finding lots of examples is a good characteristic for every mathematician, absolutely. Patient enough, they'll get to grad school by then. Yeah, that's true. Okay. We can take a G in M lambda, which sends H star into the algebra of the torus. Wait, what was H? That was part of our triple. Really? We can conjugate that into the torus? Always? unramified case, it's already in the torus, like undoubtedly, right? I mean, doesn't it have to be in the Lie algebra of the torus? Oh, I guess, right. I guess maybe just the point is we didn't necessarily choose it to be a standard. So we're just saying it can be in that torus specifically. Okay. And then, yeah, that's how you know you're cooked, Boris, is when the NLab proofs start making sense. Then you're gone. And then it's over. Okay, so then, right, if we conjugate, we get an equivalent parameter. We look at those. We take the Langlands parameter corresponding to that triple. Take its. We take that infinitesimal parameter. Okay. I'm losing the plot here a little. Okay, I guess the point is we just cook up some other infinitesimal parameter that'll help make our life easy to do this. You can't remember which NLab page it was, but a few days ago you were looking for some references, and it was actually not general enough. Wow. Speaking of posturing. I'm kidding. Yeah, but that's how you know you're really cooked forever is Arad's on a whole other level of being cooked. Once you know that NLab is not general, if an NLab page is not general enough for you, I don't know what to say. Time to go live in a little hut in France, in the boonies. I don't know. It could be both. Arad has definitely been to a parallel universe. You can't tell me otherwise. Okay, so this reduces to a root system. Just a little cute little fact about roots. That for every positive root in the Lie algebra, this should be true. This should be bigger than 1. This is one of those funny instances where this is probably more than anything else a proof that I should slowly go through, because this seems like this is like a classic technique for this sort of Lie theory type stuff. But I kind of feel like skipping it right now. It looks sort of long and technical. But we're almost through the paper. Okay, I should just read it a little bit. It's good for me. Idea number 2, read an article for the first time. I mean, that's what I'm doing now. And that's what you said below. Advertised and longer. Yeah. And shows the thought process and method. It is also good food for AI, which has to wade through a lot of human-produced BS. What? Human-produced BS? What? But yes, I should probably do more of this. And then that way I also read more papers, so I'm developing at the same time. Okay, let me just get the idea of what's going on here. So we just need to show that the eigenvalues of add of this are bigger than 1. So we use some of our facts about where this SL2 triple is contained. And that gives us an SL2 representation. Okay. This is cool. This is very cool. So we use we take an isotypic decomposition. VD is the sum, here VD is the sum of all d-dimensional irreducible representations, right? And the indexing's okay. And then I guess we're breaking up those copies of VD based on what eigenvalue they manifest as here. Most math is stuff you don't understand, so it's probably BS, yeah. As I've said before, everything I don't understand, everything I haven't read is BS. Everything I've read and don't understand is very hard and difficult. And everything I've already understood is trivial nonsense for babies. Claim NLab is all BS. You might be confusing it with MLab, the randomly generated website. Now here's the challenge. Tell the difference between them. AI scrapes Reddit and social media for content. Sure, training on scientists showing their thought process for a niche scientific AI would be good. Yeah. Is it really gonna... Are AIs really gonna, scrape the audio from my random YouTube videos? I don't know. All the math that isn't the math I do is BS. Yes, Boris. Except you're slightly wrong. It's all the math that I don't do. And you're so close because you're in proximity to me, but you miscalculated, and actually the world revolves around me. So you're very close, though. Am I a college professor or researcher? I am a researcher. I am a PhD student. I'm nearing the end. I'm applying for postdocs. I will be graduated by the spring. And I do have, I've got a preprint up on the archive. I've got another one coming. So I would say that makes me a researcher. Maybe one day I'll be a professor. Most social media are full of BS. Yeah. MathGen, good question, Rod. Frame of reference, yeah. MathGen is also a fun generated math thing, yes. Or maybe when Boris is talking about himself, he's actually talking about me, because secretly we're all one connected consciousness. It could be that too. Okay. It's so interesting psychologically why I feel an aversion to competing through this. I think the truth is, if I'm going to compute through these things on stream, I need a better setup somehow where I can see chat and have lots of writing space and see all of this at once. But okay. This is cool. I think I get the general idea of the proof. And now we come to the main theorem of this subsection. Assume that there exists a local language correspondence, infinitesimal character, then the following hold. This parabolic is G relevant, and the map, this map is a well-defined bijection. Really? Wow. Now this is interesting. Parabolic induction is a well-defined bijection. Well, I mean, so I guess there's cases where I claim that this should just be G. Triple monitor RGB revamp when. As a postdoc, I'm going to be rich. Yeah, compared to now, yes. I'll probably, have an income that's under the median. But that will make me rich compared to now. Buy a gaming chalkboard? I don't even know what that is. Yeah, I do need to sort these things out. Okay, but so it should be the case that if there is a unitary representation in there, that this will be all of G anyways. But I guess it should be all of G anyways. No, I mean, it can be all of G in other cases. Yeah. So then that wouldn't be surprising because induction's just trivial. So this would just be the identity. But what's really interesting is cases. What's really interesting to me is cases when this wouldn't be the identity. Does that even ever happen for GLN? Yes. Because, for example, right, in those cases I mentioned where, like, what are some of the cases of irreducibles that I enumerated before? Oh, it's not on the sheet? Oh, some of them are. Right, where like ones like that, these are like induced irreducibles. So of course, there's just one thing below and one thing above. Okay, so this totally tracks. Very interesting. Maybe scale down to near zero expenses, and only do math 24/7 with very little food. No, but Mr. L, I'm trying to live forever. So I need to go to the gym, and I need to do my VO2 max training. And that's basically it. And so I need a decent amount of food, and those things. But yeah, I mean, that would be crazy if I could make it as like a 24/7 streamer, math recluse, live stream. That would be crazy. But it'd be crazy if I could stream a whole, be like, okay, I'm going to start streaming. I'm going to shut myself in this apartment, and I'm not going to stop the stream until like the preprint is submitted to archive. Isn't that the default? Yeah. Yeah. Oh, interesting. So here we have the application of the PKLH here. Very cool. Very cool. Dying is gross and should be verboten. Yes. Actually, I don't know. As someone who wants to live forever, I would also respect people's choices to decide to not do that. Yeah. So, anywho, on that wild note, let you have a jab at this BS. Let G be a K reductive Artinian orbifold. Okay, already complete nonsense. Doesn't make any sense. Assume for all G and G the image of G under the Q-adic Riemannian map lies in the quotient of the unitary left G representation. Complete nonsense. It says 1 out of 2, but I'm trying to end stream here. I don't know how much longer I'm going to wait for part 2. But maybe we'll conclude our first run over this paper tomorrow. And then I don't know. Do we go back and take a deeper dive, or what? I guess we'll figure out what to do from there. The category, yeah. Well, good for you for your babbling, Lockheed. That's the first step to understanding these things. So, I'm going to support your babbling. Okay. Well, with that. It's time for all of us to go off and babble about the things we're learning. So, QED.